Yes, class. Am I audible to all of you?
Yes, ma'am.
All right. So yes, in the last class we had completed till bending of road. Some portions from this are also left. Let us complete that. Questions also we did. Yes, on a rainy day, coefficient of friction decreases to 0.2. Calculate the safe limit. So I have told you in such questions, wherever you have to find out the safe limit, you have V is equal to mu Rg as the formula. Mu tan theta or mu Rg, under root mu Rg or under root mu tan theta. So what is mu given? 0.2. Radius, is it given? Okay, it's a continuation of the previous question. Radius was 100 meters. So this becomes 100. Acceleration due to gravity becomes 10. So 200 under root 200, which can be written as 10 root 2. Root 2 is 1.414. So the answer is 14.14 meter per second. This is the safety limit. This is a continuation of the previous question. So, or do one thing, mention radius of the track as 100 meters. Quickly note it down so that we can start with bending of site, inclination, banking of road. Just few points are left in that. Quickly note this down. See, in the last class, we have seen bending of road, when the road bends. So centrifugal force acts outside, frictional force acts towards inwards, normal reaction acts upwards, and in downwards you have the gravitational force, that is weight action. That was bending of road. This is banking of road. Banking of road basically means when the road is turning, you elevate the road. All right. So you can feel also whenever you're traveling, you can notice somewhere that road is being elevated from the end. That is known as banking of road. So there is a proper angle. Now focus in here. If this is the vehicle, now inclination has been made. So normal reaction, the difference that comes here is in bending of road, normal reaction was straight. It was just perpendicular along y-axis because the road wasn't bent. Now there has been an inclination in the road. So the normal reaction is this now. So the block and the inclined plane questions we did same way. And gravitational force will act downwards mg. All right. So instead of resolving mg this time, because mg is falling downwards only, right, along x and y axis, what you can focus is you have to resolve the forces which are not along x and y axis. So this is along y axis. So how can you resolve it? Right now, we are not focusing on the inclined plane. Had it been a question of inclined plane separately, then I've told you along the plane or perpendicular to the plane. Along the plane or perpendicular to the plane. Right now, we have to focus on all the forces along x and y axis because we have to have the forces along the center, right? So friction force is acting. Now, friction force which was acting initially when the car was like this, centrifugal force was pulling it outwards. So frictional force was acting downwards. Now frictional force, what is the tendency of the body? If there is an inclination, body has a tendency to slide down. So frictional force of friction acts like this. So there's a problem with normal reaction this time and there's a problem with frictional force this time. So we have to resolve these forces. Now, see, normal reaction upward. If this is theta, again 90 minus theta, this again becomes theta. So if we take this is theta. So this also becomes theta. So here you have n cos theta and perpendicular to it means here you get n sin theta. Fine. Normal reaction was like this. Here angle was theta, so this became n cos theta. This becomes n sin theta. Not normal reaction. Normal reaction is a force, it's not the direction. Now see, why isn't it straight? Normal reaction is a force that acts perpendicular to the surface of contact. When you are having the surface like this, normal reaction will be perpendicular. If the plane inclines, so normal reaction will be now acting diagonally upwards. Clear? You don't analyze it through the base. If the inclined plane base is this, so normal reaction should be no. It's a contact force. Normal reaction is one of the contact forces in nature. So wherever the contact occurs, like if this is the contact surface, so perpendicular to it. Clear? Why normal reaction is inclined. So normal reaction has
How
been
did we get theta?
theta. See, this is theta. This is 90 degree. All right. This becomes 90 minus theta again. All right. This is your normal reaction. This is the frictional force which is acting this way and straight up to this. All right. If this is 90 minus theta, this becomes theta. Again, this is 90 degrees, so this becomes 90 minus theta. This is again 90 degrees, so this becomes back to theta. Clear?
Yes.
Now one thing, yes, frictional force again has to be resolved. So this was theta. This I told you this is 90 minus theta. This is again, this is 90. So this is 90 minus theta. Look here. Frictional force is acting downwards. This is that weight one, mg. I have written the mg here. This is mg acting downwards. This is theta. This is perpendicular 90 degree. This becomes 90 minus theta, right? Now frictional force is acting here. I have to resolve frictional force. This is frictional force which is acting, right? If this is theta, this again is 90. So this becomes theta. Why am I taking? See, 90 degree minus theta, you have, then again you have this plus theta is equal to 90 degree. It's like this, no? Total is 90. You have taken 90 minus theta, how much is left? Theta is left. So it means this angle, this is n sine theta, right? This is n sine theta. So this angle is also theta. See, this is the frictional force. This is n sine theta. So this angle is also theta. Now, again, if this is, now we can resolve this. This becomes f cos theta because this is along with this axis and perpendicular to it. It's like this is f, this is theta. So this becomes f cos theta and downwards will become f sine theta. So this becomes f sine theta. Now resolutions of vectors we have completed. That's why I was telling you when we were doing resolution of vectors that it will be repeated. This way only it gets repeated, resolution of vectors. Separate questions are hardly asked. Now let's resolve it. See, firstly, outward force that is coming. This outward force, the centripetal, okay, let's forget about the outward force. Let's talk about the centripetal force. Can any one of you tell me, out of all the forces which are occurring, which force is providing the centripetal force? I have told you that centripetal force is not a force in itself. It's not a solo force which has its own property, right? It is a force which, it is just a demand which is being fulfilled by other forces. So right now, in this case, can any one of you tell me which force is providing the necessary centripetal force? Look at the figure. This is the curve part. So center would be somewhere here. Martin, can you try?
Yeah, ma'am.
Can you try centripetal force? Which force is providing centripetal force?
mg f sine theta.
mg sine theta is acting downwards. Centripetal force acts downwards. Martin.
That's upwards.
Centripetal force acts upwards. If I give you a circle, it means you have not revised anything, Martin. Centripetal force, I have taken it as a separate topic in the last class. If this is a circle, centripetal force is acting upwards, downwards. Both the answers are incorrect. By looking at the circle, can you answer now, Martin? It is direction of centripetal force asked. Harsha has already answered half of this question. So don't worry about this question. First, tell me the direction of centripetal force. I have specifically told you to remember centripetal force and centripetal acceleration. Both have the same direction. Martin, revise it right now. Turn your pages and you will only tell me in between. All right? Either text me in between, just turn your pages and tell me what is the direction of centripetal force. Back to Harsha. Harsha, only n sine theta. Only n sine theta. Why not f cos theta? Why cannot frictional force? Friction force is also a force. This is a normal reaction. This is a force. But what about f cos theta, Harsha? What are your opinions about this? Should it provide? It shouldn't. Why it shouldn't? Yes, Harsha. N sine theta, you are perfect. N sine theta, whatever is the centripetal force, no? F is equal to mv square by r. This is this, you are right. N sine theta is provided. But I am asking, what about this f cos theta? This is also acting here. Yes, Harsha, any answer? Just tell me, frictional force, will you count this or not?
Yeah, ma'am, I think it
You
is
will
also
count it. See, whenever all the forces which are acting in that direction, you will count. You cannot choose among f cos theta or n sine theta. Both the forces are, even if there are 100 forces acting towards the center along the radius, you have to pick that. All right. And if they are in the same direction, so simply added f cos theta. Your equation is made, right? So what is your equation? What is your frictional force equal to? We know frictional force is mu n. So the force of that is mv square by r. This is the centripetal force. This is the centripetal force is being provided by this plus this. These two forces are providing centripetal force. Martin, I want the direction right now in the chat column. I have repeated.
Oh yeah.
Direction of centripetal force. So mv square by r, this becomes n sine theta plus, instead of frictional force, I can write this as mu n This is frictional force cos theta. All right. Let's take n common. If we take n common, this becomes n sine theta plus mu cos theta. If I take n common from here towards the center of curvature. Anything regarding the radius you have written in your notes, Martin? Perpendicular to the radius. Somewhat like this. Anything related to radius? Answer completely. No, complete 2 points I have made you right.
Yeah.
What? What about the radius? Perpendicular to radius.
Yeah.
Along the radius. See. If you have written perpendicular to the radius, then it means you have written it wrongly. See. This is the centripetal force. Now I'm telling you, all of you, not only for Martin, all of you, this shouldn't be repeated now. Direction of at least centripetal force and centripetal acceleration, all of you must remember it. Perpendicular to the radius means what? Force ऐसे हो गया. This is completely opposite to the prescribed direction of the force. This is along the radius. If radius is like this is the radius of the circle, so it acts along the radius, and it can be, this is also along the radius, and this direction is also along the radius. So towards the center, this is the centripetal force, and same direction is for centripetal acceleration, along the radius and towards the center. This is the direction. It is acting along the radius and towards the center. mv square by r is the formula. Revise and come in the next class, people. Otherwise, it becomes confusing. Now it's clear to all of you. Martin, clear now?
Yeah, ma'am. Yeah.
Now see, this was one equation which we had solved. This is left along y-axis. X-axis we have seen f cos theta, n sin theta. They are providing the necessary centripetal force. Regarding y-axis, n cos theta is being balanced by f sin theta and mg. So what is our n cos theta equal to? The entire n cos theta. This is actually balancing f sin theta plus mg. Again, f sin theta. Or let's do one thing. Let's bring f sin theta here minus f sin theta, and instead of f, I am writing mu n sin theta is equal to mg. So that I have, again, I can take normal reaction common. So again, if I take normal reaction common, I'm left with cos theta minus, this becomes n is taken common. This is mu sin theta, right? Mg. Now I have two equations. One equation that I have obtained from x-axis. This is the second equation I have obtained from along y-axis. So let's take the ratio of both of these. mv square by r is equal to n mu cos theta plus sin theta divided by, this is mg, by n cos theta minus mu sin theta. Normal reaction gets cancelled, mass gets cancelled. So velocity is equal to rg will go here, mu cos theta plus sin theta divided by cos theta minus mu sin theta, and this is v square, so this will become under. This is the formula of which you have to remember. This formula derivation is also there in your syllabus, and you have to remember the formula also. And one thing I'll tell you, the questions are not difficult from this topic. It's just that the derivation is very lengthy, and the questions that will come out, they'll be just formula based questions. So every value will be written, so you can easily score in this topic. One last thing is left, is bending of cyclist. So that is also similar to this part only, but note down this, then I'll discuss bending of cyclist. Any doubts in here, you people can ask. Note it down.
Ma'am, in this example, the motion of the vehicle is upwards, right?
No, vehicle is moving forward only. It's that we are not considering when the vehicle is moving forward. Velocity, acceleration, that becomes a different question, right? When the vehicle is at this particular moment, actually the vehicle is moving properly on the roads, the way it moves. It's just that when you will have a look at the cross section of the road, no, road will appear, some roads will appear like this. I don't know about your places, but here in Delhi, in CP, in places like Cannot Place and all, we have the road planned like this. So when the vehicles move from here, cars get elevated. The entire road is being elevated from here. It is at a certain angle which is calculated by the engineers. So that, but the vehicle's motion occurs straight. It's just that when the vehicle is static, at that moment we are calculating. If a question comes, then velocity, you will consider this velocity which you have calculated. Acceleration, you will consider distance, speed, the way you use your normal motion in a straight line. Chapter 2. All right.
Okay, ma'am.
Acha, you must be confused because of the friction. Friction we have taken downwards. See, I told you, no, we talk about the safety limit that is usually written on roads already for different vehicles. For trucks it's separate, for cars it's separate. This is the case that if the speed limit is exceeded, then the vehicle will have the tendency to move outwards because of centrifugal force. Remember in the last class we are doing centrifugal force. That's why
Yes.
friction has the tendency to move like. Otherwise, the vehicle is normally moving forward and friction force is acting backwards also.
So here friction is going outwards.
This is not outwards. See, this is along the slope. This vehicle, this has the tendency to move outwards like this, away from the road because of centrifugal force, right? Because of the centrifugal force. So because of this, friction force is acting downwards. Even if, just take an example, if you take a block, if you just do not move, the block will have the tendency to move downwards, right? So where will you take the friction force? Opposite, you will take the friction force here. Now vehicle has a tendency to move outwards if the speed limit is crossed. So friction force acts here. But when the car is moving, right now we are talking about the static car, but when the vehicle will start its motion, vehicle will move forward, then backwards frictional force will also act. That will be the normal frictional force, which will be equal to mu n. Simple questions which you have been solving, you will solve in that way. This is something. That's why we are discussing it separately, and the velocities formula is also different.
Ma'am, can you go up? Ma'am, is F equal to UN?
Yes, that's the formula of frictional force. Frictional force is directly proportional to the normal reaction. So when we remove the proportionality sign, the constant that we get is coefficient of friction. So this is the formula. Now, whatever be the value of n sometimes is equal to mg, sometimes is equal to mg cos theta, sometimes can be equal to a different force, whatever it is, you can substitute that. But this formula is fixed. Yes, class. Now, bending of cyclists. So bending of cyclists is also similar to the bending of roads only. It's just that when we were talking about when the roads were bent, right? When the road was bent, vehicle was straight only, no? If the road is being bent, the vehicle is straight on the road, right? If there is no inclination, vehicle is straight. When we are talking about cycle, all of you must have cycled once. So you people know whenever there are turns while turning on a circular track, or whenever we take a turn while cycling, what do we do? Do we just sit straight and cycle? Or do we bend a little while turning? If the curve is toward, let's say the curve is towards the left, so I'll bend a little towards the left, then I'll turn. Right. If the curve or the direction is towards the right, so I'll turn towards the right. You people have cycled, or you must, if even if you haven't, then you must have seen someone whenever turns are there, sharp turns or curves are there properly, when the radius, it's like a circular track, so turning occurs. So this is just what you have to keep in mind. So while bending, the cyclist is actually tilted. So when the cyclist was this, normal reaction was like this. When the road was straight, as soon as the road bent, cyclist turned, so normal reaction will also turn. This is just the difference that occurs. The rest of the things are same, like this. See, if this is the person, mg acts downwards, same thing. This is, we are assuming it to be theta, so this becomes n cos theta. This becomes n sin theta. Calculation is also very easy. N sin theta provides the necessary centripetal force, that is mv square by r, and n cos theta balances mg. Take the ratio n sin theta by n cos theta is equal to mv square by r into mg. Mm will get cancelled, nn will get cancelled. Sin theta by cos theta will become tan theta. This n will also get cancelled. So v square by rg is equal to tan theta. Velocity is again rg tan theta under root. This is the safe limit for turning a cycle. So for cycle, you have a specific case. This is actually the safe limit. This cannot be crossed. If this is crossed, cycle will skid or slip. This is the last thing that completes your circular motion also. With this, laws of motion is completed, and some portion of circular motion, that is rotational motion, is also completed. Now I'll straight away start with work, energy, and power. Work done, we'll start. So note it down it quickly so that we can start with work done. Assignment questions. See, assignment questions, now you'll be able to solve those two questions. It's like motion in a vertical circle. This is a case of motion in a vertical circle. So if a thread and a bob both are there, and when it is moving, tension acts here and mg acts outwards. Now, apart from this, T is acting upwards, mg is acting here. So centripetal force mv square by r, you will consider it this side. Now you can solve your question. T plus mv square by r is equal to mg, whatever is your question, depending upon that mass, velocity. For number of rotations, calculate the total number. First rotation, for first rotation, calculate the speed. Then for second rotation, for third rotation, for nth rotation, you have nv as the formula. Now, using this motion in a vertical circles concept, using this, now try those questions. All right. Now coming to work, energy, and power. And if Harsha still you're not able to solve the questions, text me. I'll send you the solution then directly. Okay. See, this is your chapter 6 of NCERT. Total 8 lessons are there in your first book, no, before gravitation. So this is work, energy, and power. So this chapter is also not very lengthy. It's just that you have to understand the concept of work done separately. Then in energy, work done is very small. Work done will be just completed right now. Work done is very small. Energies, you have 2 energies which have to be dealt in detail. And actually the work done is related to them. So whatever is the rest of the portion of work done, no, the main core of the lesson, that is covered along with energies. And power also. Without work done, energy and power both are incomplete. So work done, that's why we study the basics of work done. That will be completed today itself. It's a very short part and only 1 or 2 formulas are there that will be able to handle. Main thing is that energy, you have 2 types of energies, kinetic energy and potential energy, which we will see. Then we have power. All right. Power is also related to your energy or work done. So power is also a very small portion that will be completed in 1 class itself. Energy has a lot of portion, right? Because you have to deal with kinetic energy separately and you have to deal with potential energy separately. And work done is also very small. So this is not a very lengthy lesson. But from this, you have a topic that is collision. Elastic collision, inelastic collision. That I just have to confirm once whether this is still there in your syllabus this year or not. If anyone knows, please let me know. Otherwise, I'll find it out. Collision we have to do, which is apart from work, energy, and power, means this is it's a part of this lesson. It's a part of conservation of energy only. But collision is a new separate topic. Now, what is work done? Work done is dot product of force and displacement. This is the formula that is enough. This formula is enough. Work done. This means what? Suppose this is a block of mass m. Now, you have applied a force on it to certain angle. Let's say I've applied a force like this. So this is also making an angle over here. This is theta. Now, when I have applied the force, I have dragged it, so motion will also occur. The block will move. Let's say the block has moved till here. So what is the separation? Let's say the separation is S. What did I say? Dot product of force and displacement. Work done is dot product of force and displacement. How do we expand dot products? Sin theta or cos theta? Cos theta. So this becomes, you have to, for work done, you have to take the magnitude of force, magnitude of displacement multiplied to cos theta. It's a scalar quantity. This is a scalar quantity. So that's why this is a short lesson, because the questions are the parallelogram law, all the vectors, special cases, those get deleted because it's a scalar quantity. All these three, the entire lesson is based upon the scalar quantities, except for force, which comes. Force is a vector quantity. Apart from force, you have displacement, which is a scalar quantity, energy is a scalar quantity, power is a scalar quantity. So work done is also a scalar quantity. That's why this is a little easier. SI unit is joules, J we represent, and CGS unit is erg. This is written like, and 1 joule is equal to 10 to the power 7 erg. This students who were there when we were discussing units and dimensions, that time we had seen N1 U1 through this formula. N1 U1 is equal to N2 U2. So when how we have to convert 1 joules, this we had to find, and this was written in erg. So the answer to this came out to be 10 to the power 7. Check, revise this also, so that this also gets refreshed. So 1 joule is equal to 10 to the power 7 erg. 1 Newton is equal to 10 to the power 5 dyne, and 1 joule is equal to 10 to the power 7 erg. One basic question, let us see. This is saying force is equal to 10 Newton acts on a body and it gets displaced by 5 meters. If force acts as 60 degree to the displacement, calculate work done. So work done will be equal to F S cos theta. Force is 10 Newton, displacement is 5 meters, and cos theta, this is cos 60 degree. So this is half. So that becomes 5 into 5, which is 25 joules. That is the answer. Some more questions, let us see, but before that, you note it down. See, class force is equal to 2I cap plus 3J cap plus 5K cap. So I have not written the complete question. It means the initial point is this. The final points coordinates are this. It means this is I cap, J cap, K cap. This is I cap, J cap, and K cap. If coordinates are mentioned, it means you have to write the equation by yourself. That is 3I cap plus 2J cap plus 1K cap means K cap. And RB position vector. Class F S cos theta is only valid when your force is constant. I forgot to mention this over here. If your force is constant, then only this formula is valid. Otherwise, you cannot use this formula if your force is variable. Like here, force was 10 Newton. Here also proper 2I cap, 3J cap, 5K cap. This is given. This is a constant force. It's not variable. RB is 2I cap plus J cap plus K cap. Instead of writing the 1J cap, 1K cap, I'm writing it as J cap, K cap only. Now, what is the displacement that occurs? Final minus initial. So 2I cap plus J cap plus K cap minus 3I cap minus 2J cap minus K cap. K cap would get cancelled. 2I cap minus 3I cap minus I cap. J cap minus 2J cap again minus J cap. This is now the displacement SAB. Force is already 2I cap plus 3J cap plus 5K cap. Force is 2I cap plus 3J cap plus 5K cap. Now we have to, for the work done, we have to take the dot product of Fs. In Cartesian form, we don't need any angle. How do we solve it? 2I cap plus 3J cap plus 5K cap multiplied to minus I cap minus J cap. So 2 into minus 1, that becomes minus 2. 3 into minus 1, that becomes 3. 5 into 0 becomes 0. So answer is minus 5 joule. This is the work. Note it down, then we'll see if you have variable force, then how do we solve it? Because I have told you this is only valid if the force is constant. Note it, then we'll see for variable forces. Now coming to variable force. Before this, let us discuss variable force, then only we'll be able to solve. See, if you have a variable force, no, then work done. This is integral of f dot dx from x1 to x2. This is the formula when the force is variable. So every time you cannot apply your f dot ds. Like here in this question says that force is 3x square plus 2x. You can easily see f is the dependent variable, x is the independent variable. Remember in differentiation integration, I have told you, you have to check by independent and dependent variable. So 3x square plus 2x, this is the force. And we have to integrate it from 0 to 2. 0 meter to 2 meters. 0 to 2 meters. So we have the range also, we have the formula also. So F is equal to forces 3x square plus 2x. And we have to integrate it from 0 to 2 dx. This is the work done. So this becomes 3x square dx, integrating it from 0 to 2, plus 2x dx, integrating it from 0 to 2. All those who have forgotten integration, today only revise integration and differentiation. Integration especially because here integration will be used. Differentiation also will be used. All right, but in this lesson, you have more usage of integration. So please revise and come in the next class. All right, integration next. Now 3x square, how do we integrate? X to the power n is there. When you are integrating it, let's say from x1 to x2, you write it as x to the power n plus 1 divided by n plus 1. And then put the limits as x1 to x2. So what we'll do, 3x square is already there. So 2 plus 1. What did I say? This is written exactly over here. So that is 2 plus 1. And what are the limits? 0 to 2 plus. Same way here. 2. X to the power nothing means 1 plus 1. Whatever is the power goes in the denominator. From 0 to 2. So this is 3 into x to the power 3 by 3 from 0 to 2 plus 2x square by 2, 0 to 2. After this, you substitute x2 for, from here you have to substitute x2, whatever is the power with the same power n plus 1 minus x1 n plus 1 with the denominator as this is how you have to substitute. See, the best thing that here occurs is that 3, they'll get cancelled. 2, they will get cancelled. So you are just left with x cube. So that makes it upper limit first, right? x2, upper limit first and n plus 1. What did our n plus 1 come? 3 minus lower limit, then n plus 1 power. Upper limit here, 2 square minus lower limit. That is 8 plus 4, which is 12 joules. This is the answer. Note down this question as well. Note down the formula. In today's your after class assessment, the questions will be based upon this f is work done is equal to f s cos theta and work done is equal to f dot dx integral from x1 to x2. So use these two formula, you will be able to solve all the questions. It's just that you have to identify when the force is variable, when the force is constant. Please text me done in the chat column once you people have written till here.